Please welcome to the stage Kyle Langham from DFINITY Foundation.
All right. Thank you. Appreciate it. Yep, my name's Kyle Langham. I work at the DFINITY Foundation, which is a major contributor to the Internet Computer Protocol. I'm here to talk about the concept of a world computer and the incredible value that it's going to bring to AI. So if this term of a world computer sounds familiar, it's because it was actually a very common term back in the early Ethereum community. Like even before Ethereum became Ethereum, it was this idea of blockchain enabling a decentralized cloud that was permissionless and anyone could host an entire, their entire software stack. So the idea that the world software could run on blockchain. Now the OGs of Ethereum ended up pivoting. Their time to market was real important to them, so they went one direction. But that vision of the world computer lived on. There was an early contributor to this idea named Dominic Williams. He went on to found the DFINITY Foundation with the vision of creating a world computer and achieved that vision with the Internet computer. Now, it's interesting that back in November of last year, you're starting to see this talk of revisiting the world computer. You see a lot of the Ethereum OGs starting to question, should we go back to this idea of a world computer? And I think it's because a lot of people see that the technology is now viable. So again, the idea of a world computer is a decentralized cloud that you can host any software application on. There's really kind of two main reasons why people are interested in this idea. Reason number one is people look at the centralization that is our internet experience today. You can name 4 companies: Amazon Web Services, Google Cloud, Microsoft Azure, Alibaba Cloud. Those 4 companies make up the vast majority of what we experience on the internet today. So we have a high level of centralization. In addition to that, our internet tech stack has 40 years of technical debt. And so by design almost, the internet tech stack is insecure. And people recognize that blockchain with a consensus mechanism is actually a phenomenal way to secure software. So what are the features that you would expect from a world computer? Well, if a world computer is going to compete with Amazon Web Services and Google Cloud, it should have a Web 2-like experience and feature set that is comparable. It should speak HTTPS without calls, so you should be able to do API calls, like a seamless software experience for the end user. It should have incredible compute power. It should have a lot of data storage capability. And probably on the Web 2 side too, it should have a user experience similar to Web 2. When you go to Google and you do a search, you don't pay a gas fee. And if you do a transaction on Amazon, Amazon doesn't charge you the Visa transaction fee and make it apparent to you. The idea of gas is a hindrance to our industry, so it should have a reverse gas model. In addition to all that, it should also do Web 3 things, such as have sovereignty, where a DAO could actually own the software code. It should be able to compute crypto, and it should actually talk with all other blockchains. So this idea of a world computer kind of focuses on the idea of sovereign software, which is different than a smart contract, because it can be a full stack application, front end, back end, and data. Not just a small snippet of code intended to do a token transfer, but rather entire software applications. And the advantage, I get this question actually a lot. People will say, why should software be fully hosted on chain? Why can't we have Web 2 components? And a couple of the reasons: one, unstoppable. You have a permissionless cloud in which anyone can put their application on and know that it will run. The biggest reason, though, is tamper-proof. So you get tamper resistance by hosting on a blockchain. I mean, that's why we do ledgers on blockchains and not on Google spreadsheets, is because you can't tamper with the blockchain. You can do that same application with software. This is a big thing. I'm going to talk about AI and just put that in context about the amount of value AI is going to hold itself, and the fact that it's that you want that tamper-proofness, that resilience to hacks. It's worth pointing out, when you think about the Web3 hacks that we've had in the last couple of years, Bybit is a great example right now. All of them, almost all of them, have occurred on off-chain components, not on-chain components. And then there's a couple other reasons. You can keep your data private. And I'll go into some more reasons later. So again, I'm making the case that ICP is a world computer. The technical specs are needed for us to be able to host full stack applications. So right now we can do 4 gigabytes of heap memory. That's actually going to go up to 8 gigabytes soon when we roll out a 64-bit environment. This slide's actually already old. You can do 500 gigabytes in a single smart contract canister. Cost is only $5 per gig per year. You can program in a wide variety of languages, Rust, TypeScript, Solidity if you're an Ethereum developer, and so on. So essentially, I'm not saying we're feature compatible with Amazon Web Services, but what we're trying to do is approach that level to where the vast majority of software applications can host the entire tech stack on the blockchain. Just real quickly, one of the interesting things about the internet computer, and this is going to play a role in the AI part that I'm going to get to, is that data and logic live together in a single environment. So the concept of a database does not exist. I appreciate that. Of a database does not exist in the ICP world. You can engineer a database if you want to, but there's really no reason to. Your data lives as an object within the code, which reduces the technical requirements. And team, a whole host of different verticals are being built on ICP. Let's focus on AI. So back in 2023, in the summertime, a developer in the ICP community posted on the forums that he got I think it was a Tiny Stories LLM running fully on-chain, the LLM model fully on-chain with no Web 2 components at all. And that was like an eye-opening, even for us within DFINITY, it was an eye-opening because we had never even thought about the fact that you could host an inference engine on a blockchain, on our blockchain. And that kicked off a whole bunch of discovery, right? So from there, we quickly saw an image classification model that got hosted on-chain, a facial recognition model, and now we're actually moving into a state where projects are running the most advanced LLMs on-chain. So here's a tweet by Anakai. Anakai is a leader in decentralized AI. They've been floating around here at the conference, so if you do see them with like a shirt on or something, you can say hi. But shortly after DeepSeek completely tanked the world economy, if you remember when stocks dropped, it was like 2 days later, they posted that they got DeepSeek R1, a 1.5 billion parameter model, hosted fully on the internet computer and running. The reason that they are interested in this, because this is a great question, like why should AI run from a blockchain is a very common question. And again, if you're asking that question, I would repeat, well, why should we run a ledger on blockchain, right? It's that same thing. But they see it as data security. So by hosting their LLMs on chain, they can provide a level of data security to their customers and their users. Model security, this is a really big one when you consider the fact that AI agents and AI models in the future are certainly going to be honeypots for people to hack and try to steal that value. In addition to that, you can actually provide cryptographic verification to your users that they're interacting with the model that they expect that they're interacting with. And then finally, and I know Anakai's not as interested in this, I haven't seen so far, but one of the really cool things is if you're running your AI on a world computer that is integrated with all the other major blockchains, your AI agent actually can sign transactions on Bitcoin, Ethereum, Solana, as well as read the entire states from those blockchains. So if you think agent-to-agent transactions are going to become a thing, which I think most people are saying, like, yes, my agent's going to interact with your agent and do financial transactions on our behalf, it's almost certainly going to be over crypto rails, and security is going to be a big concern there. All right, so yeah, so let's go back. Like, why host AI on chain? Why host inference on chain? It really comes back to, again, this permissionlessness, this tamper resistance, so that you can your model can have a lot of value and you don't have to worry about security as much as you do on a Web 2 counterpart. and keeping your data private. One of the cool things too is we're finding that it's actually computation. So running a LLM on a blockchain is computationally more expensive than running it on a big two cloud. The replication factor is going to always mean that. However, the life cycle of the software, of the AI agent, we're finding could be cheaper because of the simplicity of hosting it on the internet computer relative to Amazon Web Services. You're not managing data going back and forth. So you, like Anakai is real big on saying like they can be a smaller dev team and produce greater results because they're hosting their LLMs on-chain and not on AWS or Google Cloud. So that's this, again, data and logic living together means complexity decreases. All right, so that's one vertical that I think is really, really interesting for the world computer, hosting AI agents. There's an entire different vertical that I think this is really where we're going to get into reaching out to where the masses of our family and our friends are going to finally start getting on Web3, is this idea of describe to create. So we at DFINITY have a product that's in development right now. We're getting ready to release our alpha release of it called Caffeine. You can see a picture of it right here. It's just a standard chat to code interface. So you describe the application you want to run. It's going to build out the code for you and then put it on ICP, the front end, the back end, and the data. It's going to put it on ICP for you. So really standard thing. If you know v0.dev, that's a similar product in the Web 2 world. Likeable is a very similar product as well. This is similar to that, except for it hosts it on ICP. But the key features, there's a key moat that we're going to have in Web 3 that they will not be able to replicate in Web 2, which is the ability to manage that application. So you built an application in Caffeine, you launched it. You're going to be able to manage the lifecycle of that software through that same chat prompt. So 3 months later, you come back and your users have requested a change to your application, or your designer says, I hate the background, or I hate this way that the user flow is. You're just going to go back to your chat prompt, describe the changes you want. It's going to redeploy that code on the internet computer and update your application live. And it's going to do so with orthogonal persistence. So if you know what that term means, it essentially means that the data that your users have already entered into your site that's being stored in your smart contract, it's not going to drop out. And that's really a moat that we're going to see Caffeine has, that it's going to be very, very, very challenging for Web 2, similar Web 2 applications to copy. And that really comes back to the unique architecture of ICP. So what does this all mean? We see Caffeine as a product that basically unlocks Web3 development for 8 billion people. Now, as simple as describing what you want your application to be, anyone will be able to come in and launch an application. Let's say like you're sitting around with your friends and you guys want to do a pool based on a random generator for who has to pay the bill at dinner. Instead of downloading an app to do that, you could actually just describe it, and in, let's say, 30 seconds, 60 seconds, you'll have your application live on chain, and then you can use it. If you don't need it anymore, you can just kind of let it drop off. If you want to keep evolving it over time and maybe commercializing it, you can keep doing that. And so that's the vision that we see, is that 8 billion people are going to be exploring building Web3 apps at that time. And we also believe that this is going to be an on-ramp for people to get into Web3 development. So even though Caffeine can build the code for you and manage that code for the lifecycle, we believe that there's going to be people who see commercial benefit in their application, and what they need to do is differentiate their application in a way that somebody else can't come and do the exact same chat prompts and produce a similar app. And at that point, they're going to take control of their code, which Caffeine allows. Your application is a smart contract on ICP, so sovereignty is a really big thing. You'll be able to take control of your smart contract, and then you can change the code and do whatever it is that you want to do. If you want to now start pivoting into like Bitcoin or Ethereum, you'll be able to do that. And so in our minds, this is how we onboard 8 billion people into crypto. They're going to be using applications that they don't even realize are running on crypto rails. That's the point. When you're on the internet, you don't know if the website you're accessing is Google Cloud or Microsoft Azure, and you don't care. And you really shouldn't care. And so we think that this is how we'll get to that stage in this life cycle where users are using crypto and they don't even know it. So that's my time. If you're interested in partaking in this, either developing or being part of the community, you can scan that QR code. It's going to take you to internetcomputer.org. And I hope to see you out there running some AI agents. Thank you.
Thank you.